Welcome back to my YouTube channel all about VLSI. In this particular video, let's start the development of Scoreboard. In our previous videos, we have discussed about a write driver, read driver, and write monitor and read monitor generate. This and all things we have developed in our previous sessions. Now it's time to develop other model, which is nothing but our Scoreboard. Now, what do you mean by a scoreboard? So basically, a scoreboard is a component which is going to compare and it is going to decide whether whatever the data is being matching or not. For example, we have a design, right? So we had a design previously, and this particular design is been driven with write logic via the write driver, and the read driver was driving the read logic. So read driver was driving the read logic, and our reference model is basically acting as the design, and this was driven by our write monitor and read monitor. So write monitor and read monitor also were also getting the data from the write driver and read driver, same via the interface we are going to get, right? Now reference model is going to give one set of data which the write monitor and read monitor has given. Accordingly, it is going to give a particular data reference model is going to give, and design is also going to give a set of data. It is a RAM, right? So we are going to read a particular data from a particular location. From the reference model also, we are going to read the data from the same location. Now we are going to compare this two particular data items inside my scoreboard, and I'm going to check whether these two are equal or not. Okay. Now the data which we are going to get it from the DUT, we are not directly giving it to the scoreboard. Scoreboard and DUT is not going to have a direct connection like this. So we are going to have the read monitor, which is basically collecting the information from our design, and it is going to give it to my scoreboard. Okay, so that is how we are going to collect the information from the DUT and going to give it to the scoreboard. Scoreboard is not going to have a direct connection with our DUT. Write driver and read driver are having the direct connections, and write monitor and read monitor are going to collect those particular informations from the interface and going to give it to the scoreboard via the mailbox. And reference model and scoreboard are going to have the direct connection using our mailbox. So this is what this particular component we are going to build. Now let's develop a scoreboard over here. So previously we were developing reference model and all. Now let's develop a scoreboard. So class RAM underscore scoreboard, and over here I'm going to have the mailbox handle of transaction. One mailbox handle I'm getting it from the read monitor, and another mailbox handle I'm going to declare transaction, which I am getting it from my reference model sb underscore exp underscore mbox mbx, let's say. And one more mailbox I'm getting it from my write monitor, mailbox hash transaction scoreboard underscore write underscore mailbox. So these are the mailbox handles which I have declared, and let me declare the new function over here. So in this particular new function, environment is going to send me the mailbox handles transaction sb underscore read underscore mailbox as one argument, and let me copy paste it. Another argument is of also mailbox handle. One second. So mailbox hash transaction sb underscore exp underscore mbox, and another mailbox handle I'm going to have sb of transaction scoreboard underscore write underscore mailbox. So these are the three arguments which my environment is going to send, and I'm going to copy it to my local copies. This dot sb underscore read mailbox is equal to sb underscore read underscore mailbox, and this dot sb underscore expected underscore mailbox, which is equal to expected underscore mailbox, and this dot sb underscore write underscore mailbox, which is equal to sb underscore write underscore mailbox. So this I'm going to copy, and followed by end function I'm going to write it out right now. So I'm going to have a and also I'm going to declare few variables. Let me declare them. Int unsigned pass underscore count, and another variable fail underscore count, and unsigned variable write underscore count for checking how many writes I'm going to have. Okay, now here I'm going to initialize them. Okay, anyways there will be equal to 0 only because of type int, right? Now let me write down a task which is basically run underscore check. This particular task is going to check my transactions. Before that I'm going to declare the transaction class handle over here, which is actual. Two transaction handles I'm going to declare over here, actual and expected, so that I can able to compare between them. So let me display scoreboard started the process sb started. Now over here within a forever begin block, forever begin, I'm going to write down over here scoreboard underscore read underscore mailbox. That means I'm going to get the data from my read monitor dot get. This is my actual data which I'm getting from the DUT, which I've shown you previously, right? So this one I'm going to get it from the DUT via the read monitor. Okay, and next is expected data, which I'm going to get it from the reference model. Scoreboard underscore expected underscore mbx dot get of expected. This I'm getting it from the reference model via the mailbox. Okay, and next I'm going to call the task which is known as check, and I'm going to pass this actual and expected handles. That's it. Okay, and followed by end and end task. That's it. Now let me have a task over here which is run underscore check. Sorry, the task name is simply check. So this particular task check, what it is going to do, let's declare it as a function because we don't have any particular delays over here. So function void check I'm going to have, and this particular function is going to have two arguments of transaction. One is actual and another is of transaction, which is expected. Okay, so these are the two arguments this particular function is expecting. And after getting this particular things, what we are going to do is I'm going to declare few variables over here, address underscore match and bit data underscore match and bit valid underscore match. So three handles I have declared over here, three arguments. Now my address underscore match will be equal to 1 when my actual transaction, this is my transaction and which is actual, this is I'm getting from the read monitor dot address, which is equal to expected dot address. If it is equal, then address will be matched. That means whatever the address which I'm getting it from the design and whatever the address which I'm getting it from the reference model, if both are equal, then my address match is equal to 1. Next is data underscore match. So this data underscore match will be equal to 1 when my actual dot data, if it is equal to expected dot data. If it is equal, then data match will be equal to 1, and valid underscore match will be 1 when my actual dot valid, if it is equal to expected dot valid. If it is equal to 1, then my valid underscore match will be equal to 1. So if these if these comparisons are true, then this particular variables will be made to 1. Now I'm going to, what I'm going to do is if address underscore match and data underscore match is equal to 1 and valid underscore match is also equal to 1, Then I'm going to increment my pass count plus plus. And also I'm going to display scoreboard pass. Display scoreboard pass it. And I can display the value of address, which is equal to percentage D. And also I can display the data, which is percentage D and all, right? Uh, and I can display the value of address and data over here, okay, which is actual underscore address, actual dot address, comma, actual dot data. This I am displaying from the scoreboard. Now, if this is happening, then we are going to display. Else, we are going to let me begin this and end over here. Now, else what I'm going to do, my fail count will be equal to 1. That means my fail count will be incremented. Let me write it down in a beginning block. So my fail count will be incremented, and what I'm going to do, I'm going to display that my address is mismatching. I can write down the particular address is mismatching, or if the data is mismatching, I can display data is mismatching and all. So I can write down over here if not of address underscore match, I can display the statement over here, $display address mismatch. And I can also display what is the actual data and what is the expected data, which I'm going to have. And also, else if my data is getting mismatch, data underscore match is equal to 0, then I can also display $display data mismatch. Like this, I can display mismatch. So this is how I'm going to write down my logic and followed by end function. And I can have one more function which is known as report function, which is basically giving me the report of each and everything, like what is the number of write number of transactions happen, what is the number of read number of transactions happen, what is the total pass count, what is the total number of fail count I'm going to have and all. I can see, and if my fail count is completely equal to 0, then the total number of tests are passed, all tests are passed. If my fail count is not equal to 0, then I can basically display some particular test has been failed. I can write this logic and I can write end class. So this particular logic I can write down and I can simply end this particular class. That's it. This is how my scoreboard is going to work. Yes. So that's about this particular session. Thank you.